Hey, physics students, Thrasher here. I thought with our last quiz coming up and hearing that quite a few students were absent on Monday when we first went over this, that I would make a video going over this page number 30, electric force or Coulomb's law. I'm not suggesting you have to sit here and listen to the 20 or 30 minute long video, however long it depends, or it turns out to be. But if you have questions or if you're not sure how to get started, watch some or bits or pieces or all of this video to help yourself out. Or if you're really stuck on one of the problems, skip ahead to one of the problems and listen and watch as I solve it. But I'm going to go through each of them. Okay? Again, this is page number 30. I maybe should have had it relabeled or pre-labeled. It's using this equation. It's an equation that describes and really quantifies the attraction and repulsion of charges. How strong is an attraction or how strong are charges repelled? Well, it's based on how much charge the two things have and the distance between them. Okay, so we're really just doing some math, but we're doing the math of that, like charges attract or repel. Opposite charges attract. I know it's easy to say that, but there is a number, there is an actual force associated with it, and that's where this equation comes into play. You'll never have to memorize like the charge of the proton or the charge of the electron, which is just the opposite. They will be given to you on the quiz. They're also on this paper, so you might hear me mentioning referring back to this front side. But I'm just going to go ahead and get started. I'm going to solve each of these problems. Again, follow along, skip ahead. Maybe you don't need to watch this at all. I totally leave it up to you. Okay? But problem number 1, it says an object has a charge of 3 coulombs. That's one of the Q's, one of the charges. Another object has an equal and opposite. What's equal and opposite of 3 coulombs? Minus 3 coulombs. Well, if they're a distance of 0.2 meters away, calculate that force. So I always write down the original equation, K, Q1, Q2, divided by the distance squared. If you want to write this uppercase E, you can't. I sometimes leave it off. I won't hold that against you. Let's plug in. What was K? You don't have to memorize it. It is on the first page. There's a little cut off here. Okay, but I'll have it on the TV or on my whiteboard when you do it. It's 9 times 10 to the 9th. What's the first charge? No guessing, no having to multiply by the number of electrons. It's whatever number of coulombs the objects or the things in the problem tell you. This case, it's 3. So one of them has a charge of 3. What's the other charge? Oh, it's the opposite, minus 3. Divide that by how far away are they? 0.2. Everybody forgets to square that denominator at some point. That's okay, I've forgotten too, but you don't want to forget on the quiz because then you're probably going to lose a point. So this is what goes in your calculator. 9 times 10 to the 9th times 3 times negative 3 multiplied by 0.2 squared. Remember, I have the answers on the bottom of the very last page, so I'm actually going to glance off camera. The answer to this one, because I'm not going to do the math, that would take too much time on camera, is 2.025 times 10 to the 12. It's a force, it's in newtons. If you got a negative answer, that's okay. Some physics textbooks and websites, they'll drop the negative, but it doesn't matter to me. Whether you have a negative number like this, or if you left it as positive, either way, it doesn't matter. Okay, there's our answer for number 1. Okay? Now, next question. Question number 3. I'm jumping to number 3. I'm only going to do the math problems here, all right? Now, for question 3, it says I have 2 small objects, one of which has a charge of 6 times 10 to the negative 6, the other 5 times 10 to the negative 6. They exert a force of 175 newtons. Find the distance. This is one of those tougher problems, team. I'm still going to start with my original equation, F equals K, Q1, Q2 divided by distance squared. But now, I want the distance. Okay? For this example, I'm not going to work through the algebra steps, but do you remember my trick? If you grab the thing on the left and grab the thing in the bottom, you can swap them. So my equation, I'll go back to green, turns into d squared equals, the top didn't change, K, Q1, Q2 divided by the force. Oh, let's plug in numbers. That's 9 times 10 to the 9th. Oh no, I'm going to run out of room, I can tell. K1 or Q1 is 6 times 10 to the negative 6. I'm going to put 6e to the negative 6. Remember that scientific notation? And then 5e minus 6. 5, oh no, e negative 6. Maybe that didn't save me much space. But then I'm going to divide it by the force. What was the force? 175 newtons. You're going to plug this into your calculator, but you got to be careful. That's what d squared equals. So you have to do an extra step. I just want the distance, not the distance squared. That's crazy. So when you take this and you plug it into your calculator, and you get d squared, you got to take the square root of that answer, and that'll give you the ultimate result. What's the answer to number 3? It's 0.039, and that's meters because it's a distance. That's question number 3. Question number 4, again a math problem. You take a balloon, you rub it against your denim. In doing so, the denim gains a charge of negative 8 times 10 to the minus 6. It gained electrons. The balloon lost a charge. It has the, in fact, opposite charge of positive. What is the electric force? Well, okay, at least in this one, we don't have to do any weird algebra. It's asking for the force, and that's what the equation is already kind of originally written as. So K, Q1, Q2 divided by D squared. What's K? It's on the front page, or on my quiz, it'll be on my whiteboard. 9 times 10 to the 9th. What's Q1? This one, negative 8 multiplied by 10 to the negative 6. What's the other charge? Oh, positive 8. Again, if you end up with a negative answer, that's okay, totally fine. Some textbooks will drop the negatives. It's a little interesting why. I don't actually need to get into it for the sake of this homework because it's not really important for us, okay? Divide all that by the distance. How far away? 0.05. Don't forget to square that denominator. Plug it into your calculator. What's the answer for number 4? I got an answer of around 230 newtons. Maybe I rounded a little different than you. If you got 229, that's probably fine, okay? But I got about 230 newtons. I realized there was a line cutting off my head, so I floated up a little bit. Number 5, find the electric force between 2 protons. Now, if you look at that, I give you the charge of a proton. You don't have to memorize it. Again, if you need it, I'd put it either on the quiz or I'd put it on my whiteboard, okay? But find the electric force between 2 protons if they're located at this distance. Again, nice. I'm looking for the force. I don't have to do any algebra. K, Q1, Q2, OPA, always write down that original equation. That's how I can follow along and give you partial credit. 9 times 10 to the 9th, that's K. Never changes. Charge of a proton, 1.6 times 10 to the negative 19. Students often miss out this one, or they miss something on number 5 because they get confused about what to plug in. I have a proton and another proton. So Q1, it's a proton. Plug in the charge for a proton. Q2, it's also a proton. Some students, I think they need to multiply it by 2. Oh, but that's not what the equation says. I take the charge of each individual object. My 2 objects are 2 protons, so you should be multiplying them. Or, likewise, this is 1.6 times 10 to the negative 19 squared, since they're being multiplied together. But anyway, divided by the distance, 0.001. Make sure you square it, plug it in. What do I get for number 5? I got a really tiny number, 2.3 times 10 to the negative 22 newtons. Okay, remember, protons are also really, really tiny. So for them, this might actually be a significant force, but it is a really tiny number with that scientific notation there. Okay, that's number 5. Next one, moving on. Number 6, it's asking if you're given the force between 2 charged objects and you're given the distance to find the charge of one of them. Number 6 is maybe the toughest from an algebra perspective. So let's look at the algebra. K, Q1, Q2 divided by the distance squared. It's asking for one of the charges. I'm going to solve this for Q2. I like to do the algebra first. Some students like to plug in numbers and then move them around. It doesn't really matter, okay? But if I'm trying to solve for Q2, how do I get it all by itself? I got to get rid of all this other junk. For example, it's dividing Q2 by the distance squared. I don't want that distance squared. How do I get rid of it? Well, I can move the distance squared over. If I multiply both sides by d squared, it cancels out. Sorry, that 2 over there was kind of sloppy. So that leaves me with distance squared times f equals k, Q1, Q2. You don't necessarily have to show all these steps, but I want to show you here. I'm still solving for Q2. I'm not done because I have this garbage. I don't want k and Q1 here. I just want Q2 all by itself. If it's being multiplied to Q2, what do I do to get rid of it? I do the opposite. I divide by K and Q1. That makes these cancel. But whatever I do to the left side, I have to do to the right side. K, Q1. But at least now I have Q2 all by itself. Q2 equals the distance squared multiplied by the force divided by K multiplied, but still in the bottom, the first original charge. Okay, now I can plug in. What's the distance? 0.007, and I have to square it. Multiplied by the force, 0.05. Take time, double read or double check, and read over the question again so you know exactly what is what. Some students like to label, okay, that's a force. This right here is the distance. Whatever helps you, that's what's important. And then divided by, what's K? It's just that number, 9 times 10 to the 9th. And then what's Q1? It was the first charge, 4 times 10 to the negative 5. 4 times 10 to the negative 5. You have to plug it into your calculator. I can't help you with that over the computer here. But if you do it correctly for number 6, you should get a number that's about 6.8 times 10 to the negative 12. And that's a charge. It was asking for the charge. Well, that means it's in coulombs. Now, is it attractive or repulsive? Well, I got a positive number here, and if this is positive, that makes it seem like it's repulsive, right? Positives and positives repel one another, okay? That might be how you interpret the second part. But the math is most important, 6.8 times 10 to the negative 12. If you got like 6.79 or maybe 6.81, you did it right. It's the same thing, okay? Number 8 is an important question because it's getting into those proportion questions, which we've seen over and over again, though we haven't yet had them on a quiz, wink, wink. How do you solve these proportion questions? In some senses, it's easier because you don't have to plug in big old numbers. But it's a little tougher because it's a little different from how you maybe approach normal math equations in your math class. But this is one of those examples where we have this kind of original equation, F equals K, Q1, Q2 over D squared. But according to this, we're changing it a little bit. Okay, now I'm taking these things, I have K, still I have Q1, but one of the charges, it says, is being moved to a different distance. New version of the equation, it says, is doubling the distance gonna cause this? So let's see what happens when I double the distance. That's what I just put in right here, not distance squared, but twice the distance squared. Well, after you do that, then you just got to do a little algebra or even just arithmetic subtraction. The top doesn't change. I still have K, Q1, Q2. Nothing is different up there. But now let's take D, and let's take 2 and D, and let's square it. 2 squared is 4. Distance squared is distance squared. So what's different between these two equations? K, K, Q1, Q1, Q2, Q2. What's the difference? I have this 1 over 4 times K, Q1. Q2 over D squared. Excuse me, I yawned in my video. So the distance, or I should say the force, has changed by 1/4. Oh, this is incorrect. It has gone down, right? It's in the denominator. It's gotten smaller, but it's gotten down by 1/4. That's a tough one. But that leads into question 9. 9 and 10 are, again, these kind of proportion questions. So nice that you don't have to plug in big numbers, but you got to think about how the equation is changing. So here's my original, the OG version, or the old version. According to number 9, it's changing. How is the equation changing? Well, it says two charges were placed nearby. They feel a certain force. What happens to that force if one of the charges doubles? Oh, okay. So K doesn't change. Q1 doubles twice Q1, right? That's how I can make it so it's double the amount. It only says one of them, one charge changes, so the other should just stay as it was. The distance didn't change this time, so that's just D squared. So now, let's just simplify the arithmetic or the algebra. All I have is a 2 here, but I can move that over here because everything's just being multiplied. So 2K Q1 Q2 divided by distance squared. So notice all the things that are the same, the same, the same, the same, the same, the same, the same. The only thing that's different is it's twice as much. So how has the force changed? It's 2 times as much as it was before. Maybe you write down 2 times as much as before. Remember, we did this with those really tricky Kepler law problems. These, in my opinion, are easier, but you got to remember, you put in the change and you see what happens. Let's try it again for number 10. I'm going to switch colors. Okay, again, it's a proportion question. So, what's the original equation? Oh, I know my handwriting is really crappy in this video. F equals K, Q1, Q2 divided by the distance squared. What's the new version looking like? Well, K hasn't changed. But it says, how would the force change if the particles were 5 times further apart? Okay, well, the charge hasn't changed, Q1 and Q2, but now I have 5 times the distance, right? 5 times further. And we square the distance, right? That's what the equation shows. So what's our little bit of simplifying? K, Q1, Q2, that hasn't changed. What is 5 squared? You gotta square what's in those parentheses. 5 squared is 25. What's the distance squared? Oh, just d squared. So, what's different? It's still the same Q. It's still the same Q1 and Q2. Nothing's changed. They're not really canceling. Maybe I shouldn't have slashed them. I'm just trying to highlight that the only difference is that I have this 25 on the bottom. I have 1 over 25 times everything else I had in the beginning. So, how has the force changed? It's 1/25 times as much. It's gotten smaller by 25. It's as if I found the force and then I divide it by 25. Or another way, 1/25 times as much. These are weird because they're a little different, but again, you're just doing a little simplifying after you plug in the change, quote unquote. All right, let's move on. The last couple questions are more classic plug and chug, kind of math questions where you're plugging in numbers. Okay, now number 11 says, what's the electric force? Oh, okay, so I start writing. K, Q1, Q2 divided by the distance squared. Between a neutron and a proton. I know the charge of a proton, or at least it's on the front page, or it'll be on the whiteboard for the quiz. It's 1.6 times 10 to the negative 19. But it's asking about a neutron. What's the charge of a neutron? This is a little bit of a trick question. Okay? A neutron, remember, it's neutral. It doesn't have a charge. The charge of a neutron is literally 0. So what's going to happen to my force equation when I plug in 0? I don't really have to do anything because 0 times everything is 0. Oh, so maybe you did a little math and you went down, oh, here, Mr. Thrasher, look at this. This is just going to be 0. So I don't even have to keep doing work. This is going to turn into 0. I'm done. Or maybe you write a sentence. Neutrons have no charge, so there is no attraction or repulsion. Oh, you could write it that way. That's why I had this as an option as well. Okay, let's jump over to number 12. We're almost done. Number 12 has a hydrogen atom. Okay, a hydrogen atom is just a proton and an electron. We know the charge of each. Again, they're on the first page. They'll be on my whiteboard. Let's figure out the force if this is the distance that they're separated in the atom. So the equation, Fe equals, again, you can write that E, but it's not required. K, Q1, Q2 divided by the distance squared. K, oh my gosh, I'm so old, I just had it memorized and burned into my brain over all these years. Q1, let's put in the proton's charge, positive 1.6 times 10 to the negative 19. What's the charge of an electron? Use the first page if you need to. It's negative 1.6 times 10 to the negative 19. All right, that's the charge of each. Divided by, how far apart are they? I forgot my equal sign. 2.5 times 10 to the negative 11th, excuse me. Let me erase that. The negative 11th. And it's a distance. I have to square that distance in the denominator. So you plug that into your calculator. You got to use it. If you're not getting my calculated answers, maybe double check your calculator, maybe email me, or maybe try to quickly see me Monday before class starts. Okay? But you plug that into your calculator, I get an answer of 3.7 times 10 to the negative 7. That's the force that's keeping these two together. That keeps the hydrogen atom together as a unit. That's a force, that's in newtons. Oh my gosh, I forgot the unit here. Oh, if you were yelling at the TV screen, oh, thank you. That's the unit there. Make sure I put the units for all these calculation questions. All right, last question. Oh, then we're going home, or you're turning off the TV and taking a snack break. Number 13, at least again, it's kind of a straightforward question. It's not a proportion question, but it's asking about the distance. We've seen a few questions asking about the distance. You should not be super shocked if it shows up on your quiz. You should be able to do this algebra. We've been practicing it theoretically for multiple handouts now. Looking for the distance. Let's write down our equation. F equals K, Q1, Q2 divided by distance squared. You could do the little trick if you want, okay? If I grab this and I grab this, I can swap their places. I'm not showing all the algebra steps. You could if you wanted to, of course, but I'm not going to for the sake of time. Let's plug in numbers. K is 9 times 10 to the 9th. Q1 in this case is -5. That's the charge of one of the leaves times 10 to the -7. That's in coulombs. The other charge, sorry, I had to extend beyond my box. Oh, it says both leaves, this one and this one. They both have the same charge of -5.1 times 10 to the -7. Okay, again, don't plug in 2 multiplied. You got to plug in each one separately. 2 charges. So 2 times, or you put the number in 2 times. You don't multiply it by 2. That'd be incorrect. Divide that now by the force. The force is 2.7 newtons. You get an answer, team, but that's what the distance squared is. You got to make sure you take the square root of that in your calculator. When you take the square root, the distance I get for number 13 to wrap up this video is 0.029. Or maybe you wrote 0.03. It's okay if you round a little different than me, but that's the answer I get for the distance. Okay? I hope that was maybe helpful, even if you just watched a problem or two. If you have questions, you can email me, or maybe you re-watch how I solve some of these. All right, but we got a quiz on this on Monday. Thanks a lot for watching. See you later.